course. There we go. Hey, welcome everybody. A little technical issue there, but welcome to the first ever MEGAVision. And I am your host. I go by retroCombs. My name is Stephen Combs, and I'm happy to be here this afternoon to host 9 MEGA65 projects that we're all going to take a look at. Well, I say 9, it's really 8, and it's about a half a project for me, which you'll see a little bit later. But we're going to have a lot of fun today learning more about the MEGA65 and many of the projects that are in development or have been completed and are going to be shared soon. So I will be assisted today by a couple of folks in the background. This is actually a Zoom meeting, so those of us in Zoom are online in a Zoom meeting, and we're coordinating, and we have our producer Lydon who is helping us. You'll hear him probably pop in. He has a presentation of his own. And then we also have Gurce, who is kind of a co-host, and it actually was the person who helped put all of this together. So we want to thank him for his efforts in doing all of this. And he'll be taking a look at YouTube chat. Speaking of YouTube chat, if you are watching on YouTube, which you should be, if you're not here, go down below, hit that chat and let us know you're in the chat room, say hello. That will be the place where you can post questions. And so each presenter will have about 10 minutes. And I've got my handy dandy timer right here, so we'll be trying to keep an eye on that. We do have one presentation that's going to go a little bit longer than that, but we're hoping that each presenter will take about 10 minutes, and then we'll have a few minutes for a question or two. Now, the good news is the conversation does not have to stop when the questions end here. Gurce has created a MEGAVision channel on our Discord. Not sure how to get to that Discord. Just go to mega65.org/chat. And you can fly right into the Discord and then look for the MEGAVision channel. That'll be there for you. Also, if you're interested in the MEGA65, this is your first time, you didn't know about the MEGA65, go to mega65.org and you can learn a lot more about this amazing project that we're going to find some really cool capabilities this afternoon. So love that. Let's see, before we get on to our other presenters though, I have the honor of showing you my first project, which again, as I said, is kind of a half project to kind of let you know how we're going to roll for this thing. So I am going to, right now, I'm going to switch over and hopefully all the technical stuff is going to work. And you can see right here, I have my MEGA65 screen showing. I've actually loaded my project. Now my project is a basic program. It's very simplistic. And it was kind of a proof of concept. And my proof of concept was, could I use BASIC to emulate different screens from Commodore computers throughout history? So it started as this kind of just a proof of concept, but then I thought, I think I want to do more with it. So right now, this is very much the proof of concept mode, and I'll talk through it as I go. But what I wanted to do is create a simulator. Now, not an emulator, that would be different, but a simulator. So for instance, I want this program to display a computer from Commodore's past, and then also some information. Now, I don't have all of that in here, but let me just talk through it. So you can see right here, this would be emulating a Commodore PET, for instance. And then what I would do is I have a little bit of history behind that, maybe some information on the page, which would be here. And then we go, this is really neat. This is exploiting the ROM of the MEGA65 to go into 23 character mode. And I found this through Gurce, who is actually online. And now there is some font substitutions you can make in some things. So I hope to work on that, but you can see the color schemes all work for that. And then this would be some more information about the next one. This is emulating the Commodore 64, which, the MEGA65 has a Commodore 64 mode, but I'm just simulating that as we go through the Commodore history. And then this one was really fun. This was a Commodore Plus4 with those funky purple colors and white background. So dealing with that. And then finally for this one, the Commodore 128, again, simulating what that screen looks like. And again, the goal is, if I can ever find time to finish this, as I'm sure a lot of my co-presenters can attest, just finding time to get your ideas out is the time that takes the most. And then that would be it. And of course, you see I have an out of data error because it's looking for more simulators in my data statement. So I tried to make it as compact as possible too. So that's just kind of my project. And again, that's just going to kind of show you how we're going to go. Now, my project presentation is a lot shorter than some of the others you're going to hear. And first on our list today, though, and I'll be taking a look in chat while our next presenter goes if you have questions about mine, but our first presenter of the day is Jim. So I am going to turn it over to Jim, who is going to share with us his 4-player joystick adapter for the MEGA65. And I have to say, I had an opportunity, thanks to Jim, to share this on one of my live streams, and it is a blast. So Jim, I am going to throw it over to you. All yours, sir.
Okay, I should be unmuted now. Thanks. Nice meeting everyone. Jim, I'm in the Chicago area in the USA. I started to put together a presentation, but I decided to do something different. So let's look and see if this works. See what disk we have loaded here. All right, this is it. So I made a program called MEGADeck. This is a BASIC65 program. And we'll run this. All right, here's my presentation on the 4-player joystick. Let me go to full screen on this. So continuing on the introduction, this is me probably about 1985, 86 on the keyboard, my friend Chris. I got my C64 probably mid 84. Here I am at high school. I went to a Catholic high school, and lo and behold, they outfitted the whole computer room with C64s. So that was awesome. That was my trading group. Me and some friends would hang out after school and swap disks and do different things. I got pretty good at BASIC, but never really progressed much past BASIC in high school. Then in 2013, I got my C64 out of the attic, got into this hobby. I learned C, wrote my first C program for the C64, started learning assembler, done some assembler projects now. I go to the Vintage Computer Festival Midwest. That was the first time I met retroCombs, and MGC, Midwest Gaming Classic, and some other shows around here. And then in January of 2023, I got the MEGA65, and that was awesome. Had so much fun with it. So onto the project. So I was having a lot of fun with the MEGA65, but I wanted to do a project. I saw Paul and Gurce had posts about this 4-player joystick interface. Paul had designed the way for the MEGA65 to emulate a user port 4-player joystick adapter using the cartridge port on the MEGA65, because there is no user port on the MEGA65 right now. So you have to do a special poke to enable it, but then with the proper wiring, you can add 2 more joysticks through the cartridge port. So the hard part was done. All the thought was put into it. Just needed somebody to lay out the circuit board. So that's where I jumped in and said I want to do this. So on this project, I had some certain considerations. I wanted to make sure it stuck out enough from the back of the cartridge port, but not too far. I wanted to make sure the circuit board was the right width, so it lined up correctly, the pad dimensions on the circuit board. The plating on the circuit board, I wanted to use gold plating, so it's electroless nickel with gold immersion plating on it. And then I wanted a nice chamfer on the front end. So I really wanted this to be per the specifications for a card edge connector, so that you know, we're taking care of our MEGA65s. So I'll go through my workflow here. And I'm a mechanical engineer by background, so it may be different than most people's workflow, but I start in a 3D CAD software and lay out the board and the radiuses on the board and everything. This one was a pretty simple board, it's just a rectangle. Then I import that into KiCad, do the PC board layout there. I was able to use the MEGA65 logo, which involves a little bit of licensing that goes back to the team, but I thought that was great. Give back to the team and use the cool logo. And a problem happened. So I sent this to the PC board houses, and they said, your board's too small. We can't chamfer the edge. you got to make your board bigger. And I didn't want the board to stick out further on the MEGA65, so I didn't really know what to do for a while. And then I started thinking, I've seen this before where boards will have a rail on the side that breaks away with, they call it a rat bite or a mouse bite. So I designed two boards back to back with drill locations in the middle. And I did that in 3D CAD, of course, and imported it into KiCad. Now I got two boards back to back in KiCad, and sent it to the board house and asked them to chamfer both sides, and they said no problem. So here, I'll show you. Hold on. So here's what the boards ended up looking like. You can see there's two boards back to back, and if you just grab them and bend them, they break apart. Now you have two boards. So that was in the end, that was a nice solution to that issue, but it took me a while to get there. Okay, let's go to the next slide. And of course, that's what the product looks like in the end. It's a pretty simple circuit board and two connectors, all wired up correctly. And like I said, Paul had done the hard work on figuring out how to do this. So of course, this project involved a bunch of side quests. So you know, I can't just be satisfied just making a board and be done with it. So I drove myself crazy with these other things. I made a disk of 4-player games, a disk image, and added a menu system that's running in BASIC that will auto-select between MEGA65 games or the Go64 games in NTSC versus PAL. So that's nice, it'll do that switching. And I made labels for the discs, and when people order a board from me, they get some labels so they can make their own disc. I got a user manual, kind of talks through some of the programming and other things and how to copy the files from a disk image onto the physical disk. And finally, another side project, this silly presentation thing that I spent basically this whole week working on that instead of practicing my presentation. So here it is. So I can demo this now, and we can see this actually work. Let me reset the machine. Okay, I'm going to take my disk and put in the disk drive. It's already mounted to the disk drive being the default drive, so I can just type boot. And here's my menu system. You can see the first one that's highlighted here, shotgun. The mode it operates in is Go64 mode. The video mode is PAL. And then there's a little text describing the game down there. And you know, this goes all the way down to about this disk and for joystick tester that I have in here. Admittedly, this is a chicken and the egg thing, right? There was no 4-player joystick adapter for the MEGA65 until now. So who would write a game for that? But there is one MEGA65 game, that's this Mega Wizards. But the rest of these are actually C64 games operating in the Go64 mode. But I forgot to plug in the interface, so let's do that right now. So turn that off. Plug in a couple more joysticks. Plug it into the expansion port. Okay. Turn her back on. And boot again. All right, well, I'll demo Shotgun. This is one of Ziha's games. So it's switching to Go 64 mode, switching to PAL. Looks like the PAL is coming through my capture device, which I hadn't really tested, so that's good. And Ziha does these fun games. They're awesome games you could just pick up and play, and they're great for parties at computer conventions. So start this game. We'll show this real quick. So there's just 4 guys on the screen. I call this 8-bit deathmatch. You run around, you grab a gun, and you can shoot from a long distance, try to shoot each other. Boom. So you can imagine this is an easy game for people to just pick up at a show and start playing and have a lot of fun. I went to a show in Indianapolis recently, the Indie Game Show, and so if they have it again next year, I want to go back and I want to set up a Mega 65 playing 4-player games on a wall projector and have the 4 joysticks there just so people can walk up and play. I think that'd be a lot of fun. And I think, Dan, you said that you brought the 4-player to your user group up in the Northwest of the United States and had a lot of fun with it too. So that's awesome. I can show you, let's go look at I don't think I've hit my 10-minute mark yet. I think
Just
I can go.
We have time for one more, Jim.
Okay. Let's, so this is the one that operates, Mega Wizards operates in Mega 65 mode. It's a work in progress. You can see some raster lines on the side, but it really seems finished to me. It's kind of like a Warlords type game, and the computer's taking over some of the other players right now, but obviously you can play with all 4 players. So that's pretty cool that there's a Mega 65 4-player game already. So, yeah, these are available on my website. If anybody wants to order any of these, they do come with the interface, labels for the discs, and the user manual. Any questions?
There were, I was looking in chat, no questions, lots of great comments. So people love the way you were displaying the images on the screen, Jim. So that was really cool and liked by a lot of people. And then a lot of just great comments about 4-player. Dan posted that 4-player games are the life of any retro party. So that's perfect. So good comments there. To Jim's point, all the links will be in the video description below. If you want to find out how to get your own, we will make sure that all that information is added in there. So let me just look one last time and see if there's any questions from the chat. Gurce, did you see any that I missed?
No, all good on my side. People really enjoyed the Mega 65 based slides, so well done there, man. Excellent.
Okay, I'll post this D81 image on Discord.
Nice, thank you.
Great. Thank you, Jim. Great presentation. And again, thank you so much for allowing me to feature the 4-player joystick port on a past live stream. So if people want to see more games, they can go check out that live stream, but they can also check out the link that we'll provide for your information so that they can see what games are included. So thank you so much. Good to see you online, Jim. Good to have you. Next one we have up is and as you see him listed everywhere, Dan Sanderson, who Dan is also the writer for the Mega 65, just a really enjoyable newsletter that goes out on a regular basis. Dan is going to talk to us about brain expletive language, just to keep it family friendly for everybody. So Dan, we're going to turn it over to you and hear what you have to say about BFK. Is that what we're calling it? BFK?
BF65, I think, is what I'm going to call it now. It's the nice, safe name for it. Yeah, thanks so much, retroCombs, and everyone for being here. Oh, I'm messing up my camera already. It's all right. I'll do slides. You won't see me. But yep, thanks very much. Yeah, my name is Dan Sanderson. As mentioned, I'm the author of Dan's Mega 65 Digest, which is a monthly newsletter you can subscribe to. I also wrote the Mega 65 Welcome Guide and a bunch of other stuff that you can find online. For today, I just wanted to share like a small project that I worked on a few months ago, just kind of a fun, little entertainment Let me set that up for you real quick. I'm calling it BF65. It's an all-new programming language for the Mega65. I don't expect anyone to use it, as you'll soon see why. This is actually a pretty famous and fun, entertaining programming language with a funny name. You can see from the screen what it's actually called. If you want to look it up on Wikipedia, you do have to spell out the whole thing. For today, I'm just going to call it the BF language. The BF language is a minimalist programming language. It's not really meant to be a serious language. You're not going to use it for anything for real. It's more theoretical or for fun or something like that. It has very little syntax and very few instructions. It was invented by Urban Mueller in 1993. His goal was actually to develop the smallest compiler. He was designing a language to see if the language design can lead to a really small compiler. He based it on a language, a theoretical language by mathematician Corrado Bohm in 1964, so 29 years previously. That was actually based on Alan Turing's Turing machine from 1936. So we design these machines for mathematical reasoning about computing and computation, and it was a great target for a minimalist programming language. The BF language has 8 instructions and no operands. Each instruction is a single character, and so a BF program is just like a string of incomprehensible characters. You can even see on the screen here, this is an example of a very short program. The BF machine has program memory. This program is written into program memory. It's read-only memory. These programs are not self-modifying. And there's an instruction pointer that says this is the next instruction I'm going to execute. It operates on data memory, which is a large array of byte values, and there's a data pointer pointing somewhere in this array. And so these instructions will operate on either the value in the data array that this pointer is pointing to, or it will manipulate the data pointer, or it will manipulate the program instruction pointer. The BF language also adds input and output streams. This is just a practical consideration for if you want to write a program that actually does something on a modern machine just to make it more fun. Urban added a couple of instructions that will take inputs and outputs from, say, files, right? So this is the instruction set. These are the characters, the single characters that represent the 8 instructions. We have the angle brackets are instructions that move the data pointer to the right or to the left. You can increment the value at the data pointer or decrement it. You can output the data pointer. That period in instruction is the output operator. So whatever is at the data pointer is pointing at, that is what gets written to the output stream of the program. There's also a way to accept input. So the comma operator says whatever is coming in from the input stream, store it in the data region where the data pointer is currently pointing. The most interesting part of the language is actually these square brackets. This is our control structure, the only control structure in the language. It can do loops and conditionals and stuff like that. And it's in the form of these square brackets. The opening square bracket basically says if the data pointer is pointing at a value of 0, then we don't need whatever's inside the brackets. We jump past the matching closing square bracket. And similarly, when the instruction pointer gets to the closing square bracket inside the brackets, it checks to see if the data pointer is pointing at a 0. If it's not pointing at a 0, if it's non-zero, then it jumps back to the beginning of the control structure and starts again. So you get some looping and conditional capabilities there. The data cells are byte values, and they do have overflow and underflow. So if the data pointer is pointing at a value that's 255 and you increment, it'll go to 0, and also the other way around. The input stream is a little bit interesting. You have to signal end of file somehow, and it is just part of the BF language definition that if the comma operator has already reached the end of input, it just won't do anything. It becomes a non-operation, which is really interesting. It affects the way you deal with input data, or sort of limits the way you do that. You have to treat null as a special value. The 0 is a special value that says, okay, I've started out with a 0 in the data array, and then I tried to read from the input stream. The 0 didn't change. I'm going to use my brackets to test it to see if it changed, and it didn't change. That means that it's the end of the operation, or end of the input. Brackets can nest, so you can have outer brackets and inner brackets, and they must match. If the brackets don't match, then the entire program is invalid. Most implementations of BF will pre-scan the entire program to make sure that the brackets nest and then just refuse to run it if they don't. The only way to terminate a BF program is for the instruction pointer to go off the end of the program. So you have to write your program in a way that it ends when the pointer goes off the end. We can visualize a BF machine like this. So here's our program space with a program pointer, the data space with a data pointer, and input and output streams. And here's that program we've been looking at on the screen so far. It's a very short program. This program calculates 2 plus 5. And the data region starts out all zeros. It's part of the definition of language that it starts out all zeros. So the first thing this program has to do is load the values 2 and 5 into the data region so that it can then operate on them. So that's what happens here. The instruction pointer is pointing at the increment operator. And so when that executes, the value that the data pointer is pointing at goes up from 0 to 1. We do it again. You see the instruction pointer is moved over. And so we do it again. And that now it's a 2. The angle instruction there, the sort of right pointing angle bracket, moves the data pointer over to the second cell. And as you can see, we can just increment 5 times, and then we've got a 5 in the second cell. The interesting part of this program is in the brackets here. So we have an opening bracket, and remember the opening bracket, when it's pointing at a non-zero value, will enter into the loop. So it just moves into the next instruction. This loop will go back to the first cell, increment it, then move over back to the second cell and decrement it. Now, instead of a 2 and a 5, we have a 3 and a 4. The data pointer is pointing at a non-zero, so the closing bracket is going to jump back to the beginning of the loop, the matching bracket, and then it's going to do it again. It'll move over to the left, increment, move over to the right, and decrement. Now we have a 4 and a 3. And you can see what's doing here. It's destructively taking all the value from the second cell and accumulating it into the first cell. And so as it goes through this, it'll do another loop, and there's becomes a 5 and a 2. One more run becomes a 6 and a 1. And finally, one more run becomes a 7 and a 0. Now the data pointer is pointing at a 0, and the instruction pointer is at a closing bracket. The closing bracket says, that's a 0. I'm going to move on. And so it moves the instruction pointer over. And of course, now we're past the end of the program. So BF knows, oh, the program is over. We're done. And this program has successfully calculated that 2 plus 5 is 7. The result is in the first data cell. This is a bit of a longer program. I'm not going to step through this one at a time, but you can stare at it and sort of see generally how it works. That first line looks a lot like the previous program. It's got some pluses and some moving around of the things and some loops. You can tell that it's going to prepare some numbers in the data cells. This program has dot operators, so it actually is going to output the values in these cells to the output stream. And of course, what it's doing here is it's generating a message. The message is hello world in ASCII. So you see there's like the double L's. It like gets to a data cell and makes sure it's got an L, the letter L in it, and then it outputs it twice and so on and so forth. And you can see our output stream says hello world. So I was thinking about like, how do I want to do this for the MEGA65? I didn't want to put too much effort into this because I knew nobody was going to write a serious program in this language for the MEGA65. It's more of a toy. It did occur to me that I would make like a little user interface similar to what we just saw on these slides, where there'd be a program space where you would edit your program, and maybe a debug visualization of the data region, and the input and output streams would be in little panes on the screen and so on and so forth. That was too much effort. I didn't want to do that for this. I'd love to, build something with a fancy UI at some point, but it's not going to be for this. And then I started thinking about how a lot of other Commodore 64 programs did this. Applications, especially programming languages, did a lot to take advantage of the built-in features of the kernel and the basic editing environment that was already built into the machine. Some of them just used the screen editor, so it was a custom environment otherwise, but you could move the cursor around just like you can when you're editing a basic program, and wherever you hit the return key, that's when this thing would kick in and do something. Some of them went as far as to use the basic line editor itself. My favorite example is an assembler that was published by Computes Gazette magazine called Fast Assembler. It's a very short program for an assembler. You think, oh wow, it has to be big and sophisticated, but it only takes up like 1 page in the magazine of it's like all hexadecimal numbers that you have to type in to get it into memory, but it's a full assembler. And the way it works is that you use the basic line editor. You actually give line numbers to your assembly language source code as if it were a basic program, and then you invoke the assembler. It would just scan the basic program memory and convert that into a machine code program. So that's what I did. BF65 uses line numbers. It uses the basic editor. You just type this stuff into a program as if it were a basic program. And this works because with some restrictions, the basic line editor will allow you to type pretty much anything into a basic program. It doesn't have to be basic, and it doesn't notice that it's not basic until you try to run the program. So this is a convenient way, sort of convenient way of implementing a custom language if you just want it to sort of sit there. There's some magic details involving tokenization that you have to deal with in your own program, but otherwise you can totally get away with this. So you use the basic line editor to write your program code, and then with the BF65 interpreter loaded in memory, you just execute your program with a sys command. This will invoke the interpreter, and the interpreter will scan the basic program code and treat it as a BF65 program. So let's see what that's like. My sound is going to change a little bit as I scooch over to my MEGA65. I'm going to start by setting the bank to 0, and I'll show you why we do that in a second. But then I'm going to beload the the BF65 interpreter into memory. There it is. And then we can enter our program. So line 10, let's set a 2 in the first cell. And we move over and set a 5. And then we implement our loop. So if I can remember it correctly, let's see here. We go back and add 1, and then go forward and subtract 1, and then we close our loop. And now we can just say sys 1800, and there, it did it. We can't see it, of course. We didn't have an output instruction or anything like that, but you can imagine that the data cell has done the right thing. But we can actually see the contents of the data cell. So memory in this case, the data region is in MEGA65 memory, and so we can say peak, it's print peak, I'm using the question mark, at hexadecimal 8800, that is the beginning of the data region, and you can see that it has been set to 7. One of the things that I'm kind of proud of with this is that it was easy to implement this feature where the BF65 interpreter, when it scans the program, it can ignore things that aren't the program. So there are 2 ways it does this. The one, and probably the most useful way, is that when it gets to a basic line, it'll check the first character and see if that first character is a BF65 instruction. If it isn't, it ignores the entire line. It just skips to the next line. So you can have entire lines that are not BF65 code in line with your program. That allows you to do this. All those commands I was just typing, I can just put as a basic program at the beginning and then have my BF65 code later in the listing. This allows me to write a program that is self-starting. I can load up a BF65 program and just type run, and it'll just work because the run command invokes the basic interpreter. Basic will go through and execute bank 0, bload BF65, and then it'll invoke the interpreter with sys 1800. And when it does that, the BF65 interpreter kicks in, goes to the beginning of basic memory, says, oh, these first 3 lines are not for me. I'm going to start at line 10, and then it will execute the BF65 program. Then when it's done, it returns control to the basic program where the next instruction is going to be print peak 8800. So it prints the value in the first cell of the data region. And then most importantly, it ends. So the basic interpreter gets the end command. If we didn't put that end there, then it would just proceed on to line 10, and then basic would freak out because that's not a basic instruction. It doesn't know what to do. So the end is important there. And the data region starts at 8800. It's actually part of the BF standard, language standard, that if there's program text in the program region that is not a BF instruction, it'll ignore it. So in a standard BF program, that's a way of doing comments. You can do inline comments as well. And so I implemented that for BF65. So you can just put comments on the same line. Importantly, these ones cannot contain BF instructions. So you can't use pluses and minuses and stuff inside the inline comments. Otherwise, it'll interpret those as actual commands. But the basic ones, when the line starts with a non-instruction, it will ignore the entire line no matter what's on it. So just a couple of sort of cleanup technical details. The input region, I did not implement any disk IO for this because who cares? So the input instruction reads from memory. There's a region of memory that's reserved as the input buffer, and it'll read up to the first null byte or up to 256 bytes, whichever is shorter. And so once it reaches that ending, it'll just not do anything after that because that's standard behavior for the input instruction. The output instruction writes to the terminal, so it just prints to the screen. No limit. If you manage to write a BF program that fills the screen, it'll just scroll as if you were printing something. The output is in PETSCII. I'm not converting the values in any way. A lot of BF programs you find on the internet, of course, were written to output ASCII characters, and so that will be a little bit weird in BF65. Data memory starts at hexadecimal 8800 in memory. Which allows for about 26 kilobytes for the program, including the line numbers and other stuff, if you dare write a 26 kilobyte BF program. And about 30 kilobytes for data, in theory. These are sort of theoretical limits. As you can imagine, if it's going to start at address hexadecimal 8800, that 30 kilobytes runs to the end of the first 64 kilobytes of the machine. And on the MEGA65, a lot of that memory space is used for IO registers and ROM code and other things. So if you really want to use a lot of data space, you do have to do some basic commands at the beginning there in that preamble to set up the memory system the way you need it. In theory, you could write a BF65 program that kicks the data pointer all the way into the IO registers and manipulates the IO registers using BF code. I'm not going to try doing that, but you're welcome to try. It'd require a lot of looping to get it out there and stuff. I don't know if it'd be fast enough to do sound effects or anything really serious in terms of graphics, but in theory, you could do it. So I wanted to show off a couple more demos. The disk that you can get on FileHost has a couple of things. I'll just load that. So the programs here, the 2+5 is the one we just saw. I did write a version of 2+5 that outputs the result. I don't think I even wrote it. I think I'm sure I copied it off a wiki page or something like that. But you can see here to do that. That number that's in the data cell is a 7, and to output it as an ASCII character 7, you have to add a bunch of data to, you have to increase the value to the ASCII code for 7, not just the number 7. So the first part of this program up to line 70 is the same as before, and then lines 80 through 130 actually just add a bunch more value to that 7 to make it the ASCII code for 7. But now when we run it, notice there's no print statement in the basic preamble for this one. We're going to let BF do the printing, and it does it. It prints a 7 at the end. We'll do that hello world real quick. Also, I wanted to show that off because it looks ridiculous when it's all sort of squished together like that. But same deal, it's letting the BF program do the outputting. So when I run it, it'll just print hello world, and it is printing it in ASCII. So I have to do a mega shift to switch into lowercase mode. You can kind of get a sense of what it was trying to say. And finally, I really like this one. ROT13, if you haven't heard what ROT13 is, it's an encoding mechanism. It's a very simple encoding mechanism. I'm sure we've all translated or encoded secret messages by taking the letter and then adding 1 to it. So an A becomes a B and a B becomes a C, and then it's like a secret message. ROT13 is the same thing, but you go 13 spaces. And what's special about ROT13 is that there are 26 letters in the alphabet. So by kicking it halfway down, the encoding mechanism is the same as the decoding mechanism. So A becomes, I forget, it's like M or something like that. And then when you want to decode, you just run it through the same algorithm, and the M becomes an A again because it goes past the end of the alphabet and rotates back to A. And so a ROT13 program does that to a message. You can see this is what it looks like in there. And I'll show here, if you go look at the beginning here, my basic preamble in this case is loading the encoded message into the input buffer. So this program is going to read a message from the input buffer and rotate it 13 ahead to decode it. And of course, it can be an encoder as well. But once I've preloaded the thing, then I invoke it and it will print the decoded message. So the encoded message is on line 20 there. They're for whatever that is. And then I can run this program to see what this message is. And it is secret message.
And Dan, that's at 18 right now. So just so you know.
Okay, thank you. I'm almost done. I really love the speed at which this animates. It shows how much work the BF interpreter has to do to get this. I just think that's funny. So the interpreter itself is written in machine language, or it's written in assembly language. And I'm not going to do a language tour. Obviously, I don't have time, but I might do this in a follow-up video or something like that if anyone really wants to see it. There's some fun stuff in there. I hope it's pretty easy to read. And if you want to read the source code or download any of it, it is at github.com/dansanderson/bf-mega65. You can also get it on FileHost. I have a D81 disk image you can download. Everything I write, I do a bunch of blogging about programming and stuff like that, and especially for the Mega65 is on my website, dansanderson.com. If you want to subscribe to Dan's Mega65 Digest, and I hope you do, you can go to m65digest.substack.com. I also post to the digest to dansanderson.com if you just want to read it in a feed reader or something like that. And that's all I got. If you have any questions, let me know. Otherwise, thanks very much.
All right. Thank you, Dan. And Dan agreed to let his question time go because he knew he was going to take a little bit longer. So thank you for that, Dan. And if you do have questions, don't forget mega65.org/chat and then join the MEGAVision channel. Now, going from BF65 to another programming language, we are going to look at Rust programming on the Mega65, and we have Wombat with us. So Wombat, we're going to pull you up here and let you have at it, and I will get your timer started.
All right, now I think you hear me.
We do. Thanks. Gotcha.
Great. All right. So yes, right. So yeah. Now we're moving on to Rust, and of course we could always let me hide that one here. So why on earth we want to run Rust on Mega65? And there are some. I will not give a huge introduction to Rust, but just mentioned that it's a systems language. It's on par with C, I would say, and at the moment it's the only language besides C that's accepted into the Linux kernel. So it's a fairly new language, but it's meant for really it's a systems language, so you can program hardware in Rust. So we could also say that it's the highest level language that we can run on the lowest level hardware. And as we'll see, it's actually possible to target the 6502 processor using Rust. Some of the features of Rust is that it's the compiler guarantees that if we compile, there's no undefined behavior. And that's very much unlike C and C++, where it's up to the programmer. So it's safe in that sense, and that's one of the main features that you can program safely. You can also program unsafely. It's fully possible, but if you do, you have to be explicit about it. So it has some. If you're coming from the C and C++ world, you will really be spoiled by the build system. You have something called cargo that will handle the build, the dependencies. You can even publish your software using that tool. You can do static analysis, linting, so on, and has a lot of modern features like iterators. It has traits, functional style, and so on. At the same time, you can still do unsafe stuff as in C, so you can have pointers and all that kind of stuff. So it's a fairly quickly you can build up something that's rather advanced. And one example is this tool that I wrote, I think last year sometime. It's also on the FileHost. It's a small tool that can communicate with the Mega65 using serial connection. And I'm not really an expert in Rust programming at all, and this was one of my first attempts to program for Rust. but still you could make a quite advanced tool that accesses the file host. It has a text user interface, could do disassembly, disk image support, and so on. In quite quickly, you could do that, and mainly because you have access to high-level features. It looks something like this, where you see here we can probe the file host using HTTP. You can download files and send them directly to the serial port on the MEGA65. But I think that today we are going to talk a bit more about how we can actually run Rust on the 8-bit hardware. And I want to talk a little bit about how that came into place. And the whole reason for this is that we have the LLVM, which is a compiler backend, and it's most famously it's used for the Clang compiler for the C and C++ compilers on Linux and Linux systems. Rust is based on, Rust uses the LLVM backend for code generation. So these two, they go hand in hand, you can say. And a few years ago, someone made a fork of LLVM targeting MOS, so 6502 processors and derivatives. Daniel here and John, they have done really incredible work in getting that to work. I think it's a quite difficult thing to do, but it's a quite stable compiler now. And for example, for C and C++, we can do modern C++, and you can run it on 8-bit systems. So sometime after that, since we now have the LLVM MOS backend, Marius made a version of Rust that is using that backend. So it actually didn't take that much changes to the Rust project to adapt it to the LLVM MOS. And that's the reason we can run Rust today on 8-bit computers. So to get it to run on the MEGA65, there are a few things that needs to be in place. And first and foremost is a linker script. We need to be able to give it a basic header and where to load and so on. This is not strictly necessary, but it would be nice to have a bit more code generation for the more modern processor in the MEGA65. So these are some of the things that I've been focusing on, and I also added a Commander X16 linker script. And maybe I shouldn't say this in this forum, but I think the synergy with them is quite important, because the processor here, anything that goes into that processor here, we are going to benefit from in the MEGA65 community. All of this is now up into the, it has been accepted into the LLVM MOS project, and it's available now. I've also been focusing a little bit on making the MEGA65 libc available for the Clang compiler, and this is useful because we can use that in Rust as well. I've made a support crate which is targeting CBM-like targets like Commodore 65, MEGA65, Commodore 64, MEGA65, and so on. And I'll go show you a little bit about that. If you want to know about the code generation of the LLVM MOS project, you can just go to the Godbolt Compiler Explorer, and it's actually available in here even for the MEGA65. So you can start to write C or C++ code and see what kind of assembly it can generate. Just if you're curious, you can do that in your browser right now. This is a small example comparing C and Rust on the Commodore 64. And this is a classic plasma example that's often used in compilers. And here we have LLVM, and you see that it generates quite similar speed. And the difference is that in Rust, we use iterators, we use closures, which are also known as lambda functions in other languages. So we'll look a bit more into that shortly. So what I think the easiest way to do this is to simply show you how this works. And so here we have Visual Studio Code, and I have now this RustMOS crate open, and I'll let you show you some examples here. So for instance, we can go into, let's see here, we can go in and have a look at this plasma example. So this is the example we saw before, but adapted to the MEGA65. And if you're familiar with C, this is not too alien to you, I think. So here we have the main function, and you can see we set, for example, the character set where we want that to be, and we have our plasma routine is nicely wrapped inside a struct. We set the character set, and we slow down the machine a little bit, otherwise it will run way too fast. So we are setting this to 3.5 megahertz. And then we are running an infinite loop where we render the routine. And I can show you how that looks. So we can now start to see here. So see. So that's the example here running in on the MEGA65. And just to give you a flavor of how Rust looks like and what you can do. So first of all, we are inside the Visual Studio Code, and we have access to all the information. You wouldn't know that you're targeting an 8-bit platform here. I can show you a little bit the style you can program in if you want. So you can do functional style programming. Here we have we are looping over an array, and we're filtering, we're folding. So we can do quite advanced stuff that looks like a really modern language. And just if we try to, if we just have a look, files here. So let's go back, and you can see we're ending up with still a rather small binary. I'd like to just show you a slightly more advanced example. So here we have, this is targeting the Commodore 64. And this is a small demo where we have, again, if we go down to our main function, we are now setting up a scroll text, a sprite, and we even include some music in a routine, in an interrupt. And here we can do, let's try to build it.
And we are at 10 minutes, just keep you on time.
Right, thanks. I'll show the example and move forward. So let's see here. So if we show that small example, and maybe here I need to actually share some sound as well. So let's see how that runs. So I think when you see on your screen, it's probably lagging a little bit too soon here, but on my screen, it's So with that, let's just go back to slides, and we have a little bit of features that we can do in Rust. We can do some things that looks advanced, things that look a little bit more like you can hide things away. For example, here we have a random number generator that we from the MEGA65 libc, and we have wrapped it into we've given it a trait. So it can be used throughout Rust as it was a normal random number generator on a modern machine. We can also work with DMA copy, so we can access memory. We can copy that back and forth completely transparently, but it needs to be handled specially here. So let me just summarize a little bit here. So Rust is quite operational. You can run it on Mac or Linux. You have to cross-compile. You cannot run it locally on the machine. And the LLVM MOS project has advanced quite a lot. And I think now we have even code generation spilling in from the the Commander X16 project. But there are still some things to worry about. And I think that gurce might talk about that a little bit. We have to deal with binary size, make sure we don't pull too much things in. Yeah, that's about it for me.
Thank you so much. That was I love the demo at the end. Thanks for sharing that. And I'm looking in chat. I don't think, let's see, gurce, did I miss anything in chat? I think most of the comments were very impressive. People loved what you were doing. A lot of comments about the Rust programming language itself. So some really good stuff there. Gurce, did I miss anything?
Pretty much covered it. All good there.
Great. So we're going to move on from software. We're going to go back to hardware, and we are going to look at the MEGA65 running on the Wukong board. As a matter of fact, if you look, right here, right there we go. This is running on a Nexus 4 FPGA, but there is a less expensive option out there, and we're going to hear about that now from, and the handle is 0XA000. So we're going to turn it over to you, however we would say that. So let's throw that over to you.
Yes, thank you. Hi, I'm Joris van Zuyten, and I wanted to tell you something about running the MEGA64 on the Wukong board. Let me first try to share my screen. I hope this is visible. So I came to I joined the Discord maybe 2 months ago because I wanted to learn more VHDL, and I was looking
again
for...
the wrong screen.
Ah,
just
really?
That you, yeah.
Sorry. All right. Better? Is this?
Seems the same. It's still on presenter mode.
All right. But I switched the monitor. All right. Maybe. Sorry. Let me try again. This better?
Yep. All good now.
Yes.
Yes.
Okay. Okay. Sorry about that. All right. So yeah, I joined the Discord some 2 months back to learn more about VHDL, and I was looking for interesting topics. And the only FPGA board I have is this Wukong board. So I thought maybe the first step is to try to get the MEGA65 to run on it. Short something about the Wukong board. It's like it's indeed I think it's similar to the Nexus. It has the same FPGA, but it's like a bare bones version of it. So it doesn't have all the switches and 7-segment displays, but mainly a lot of user I/O. It has HDMI out, Ethernet, underneath a micro SD card slot, and a USB to UART bridge for connecting to the serial monitor. And on the side here, it has 2 PMOD connectors, and then here's a large pin header with general purpose I/O pins. And it's a low-cost board. It costs about 125 euros. The only problem with this board, as far as I could tell, it seems to be going out of production, or I couldn't really find new boards online. But I did see that it seems the board is produced by a Chinese company called QM Tech, and they seem to be moving to a slightly different type of boards, where they have core boards, which only contain the FPGA and the memory chip. And then they have one daughter board, which can be used with all of the different core boards. So that's kind of their new setup. And the price is, if you combine it, it's similar. It's just that instead of HDMI, you have a VGA connector. And all the user I/O pins, which are on this big header, are a bit more difficult to get to because there's no pin header on the daughter board. So getting to run the MEGA65 on this FPGA board, I noticed a MEGA65 blog post that there were already some, I think, HDMI tests done with this board, and there was already a build target in the MEGA65 repository. So there's a top-level VHDL file, constraints file, and also a make target. So in principle, using the make line here, you can build the bit file, but that didn't work, and that's mainly because, well, basically the build target needed a bit of TLC. It was running behind the development, I think. So with the help of people on Discord, it was basically just some files missing, some signals which needed to be added. The clock, the 50 megahertz clock module needed some changes, but it was all pretty easy to fix. And there's a fork at this address which has all the changes. So using that, you should be able to run this this make command and produce a bit file which you can then upload to the board via JTAG. So you need a JTAG cable for that. So suppose then that you do all that, what will you end up with? At the moment, what works is video over HDMI and also sound. I tested two somewhat older LCD panels. One is from Samsung, the other was from AOC. The Samsung worked, the sound, the AOC didn't. So your mileage may vary depending on what monitor you have. To have some input, I tried connecting a physical C64 keyboard basically directly to this user GPIO pin header. I'll tell a little bit more about that in a second. Then the micro SD card works, so you can load disk images, and also the serial monitor, which can be useful for debugging because you can look at the output on the serial terminal of the MEGA65. Then things that didn't work. So this was actually on the right, the first image I saw when I loaded up the bit file. And this is the flash menu, which cannot interpret or cannot determine the page size of the QSPI flash. And that is because the flash chip on the Wukong board is a bit different. It uses something called serial flash discoverable parameters. And it's sort of an area in the flash which describes the geometry of the flash chip, and that usually for the MEGA65 boards, those flash chips have a different way of doing the same thing, which is called Common Media Flash Interface. So I mean that just didn't work. So for now, I disabled the flash menu in the fork. The other thing that was causing problems was the random number generator. This is called a NeoTRNG VHDL component, and it was causing some issues in the synthesis. So I also disabled it, but it seems that it works on the Nexus board, so it shouldn't be too hard, I think, to get it working. So a quick overview, should you want to try to connect a C64 keyboard to this pin header, this is the way it's connected. So on the top you see the C64 keyboard connector, and here's the pin header on the Wukong board. And basically they're both 20 pins, but they cannot be connected one-to-one because of these supply pins here. And also because this pin is blocked, so it's a key. It's just connected, shifted. So pin 4 of the C64 keyboard connector is connected to pin 1 of the user I/O header. And it looks a bit scary because we're connecting a positive supply pin here to ground here, but this pin is not connected to anything, so it's fine, doesn't matter. When I tried to use the keyboard, I had a lot of problems with keys registering as different keys. So for instance, you would type W and you would get R, or you would type T and you would get U. And those are actually the next key in the being scanned. So there seems to be something going on there. I also saw a comment in the VHDL code that mentioned something like this. Also, some keys didn't register at all. So I tried to implement an alternative scanner in VHDL. I don't know that much VHDL, so I sort of iterated by trial and error to something that seems to work reliable. There's 2 changes. Basically, the scan rate is much lower. And also I tried to clear the input pins by driving them high before scanning each time. I don't know if that seems to have made things more reliable, but actually I don't know exactly what the problem is and what part of this is being a solution. Could be anything, maybe just the lower scan rate is already enough. But synthesis runs on my laptop were taking 45 minutes, so I didn't really feel like digging into it very deeply. But you can use this alternative scanner. It's added to the file list by default in the fork. The scanner is not C65 keyboard compatible, unfortunately, at the moment. Okay, some things, some more or less random list of things I think that might be nice to do in the future. One is routing the joystick signals to the PMOD to PMOD connectors, like also for the Nexus. I think there's a PMOD to joystick converter. Find a way to connect.
This is your 10-minute, okay?
Okay, thank you. I'm almost done. Okay, yeah, find a way to connect the restore key because that's currently sticking out of the side of this user IO header, and it's not easy to connect. Fix the flash menu, so implement a reading routine for this other discoverable parameter array. Test and fix all the other components like Ethernet or the IEC bus for connecting drives. And what I think what would be a very cool project is to design a custom daughter board for one of these new core boards for QMTech, which is basically specific to the MEGA65 use case. So you can then do all the connectors right, so to say, and you just have sort of a plug and play thing. So that's it. If there's any questions, please let me know.
All right, thank you so much. Let's check and see if we had some questions. Gurce, did you see anything?
Not yet, just chipping in to say it's good to see people solving problems on the hardware and software level. So thanks for your efforts there, man.
Yeah, I agree. This is one I'm really excited about because that little board right there is pricey. So as they come out with a newer version, hopefully more people can get into a hardware version of the MEGA65 and then start to add some components to it that make it feel a little more natural, more like a real computer while we get more of the originals out, so or the new MEGA65. So thank you for your work on that. I know I've been watching you on the Discord, and that has been quite a challenge for you.
Oh, sorry, David Morings popped in and asked, how long did it take you to work on this?
Sorry, how long did it take to work on this? Well, I think it was on and off a couple of days to get it working. The keyboard scanner took a bit longer, but maybe like 3 or 4 days.
Nice. Sorry, on mute, Richard.
There we go. All right. So thank you again for the time that you spent on this. And now we get to go ahead and roll back into software a little bit and go to kind of our co-host today. Gurce is going to talk to us about the 11 improvements and progress on rewrite of a compile phase. We're going back to Rust. So Gurce.
All right. Thanks for that, retroCombs. And yeah, apologies for my minimal understanding of OBS Studio. I just arranged things on the screen abruptly. Talking about shortcut keys for 11. But yeah, my talk today is on the 11 BASIC65 IDE, and I'll also touch on our attempt to rewrite the compile phase of this IDE. And the notes I've got in the bottom right here have been written with the megawatt tool, which is like our PowerPoint equivalent that Luck132 had written. And yeah, so we'll just dive into it. And I'll say, so what is 11? It's like an IDE-like experience for BASIC65 with some extra perks, long variable names, labels you can use for GoSub and GoTo. So you can write smarter code with BASIC, which can then compile down to the dumber Commodore BASIC form. So the history of 11, it was written by Stefan Kleinhardt, who goes by the name Ubik in Discord. And I'd say it's for writing ambitious level BASIC programs, and you don't want to get limited by old BASIC limitations. And around last year, I started making some mods to it where I needed to make improved things. I asked Ubik, was it okay to make this open source? And he said, yep, that's fine. Why call it 11? Lubick said it was due to a spinal tap joke, but for me, I imagine it relates due to Commodore's last BASIC being BASIC 10, so his 11 was aiming to improve upon 10. And why care about 11? And honestly, at the beginning, I didn't. Like when I had my MEGA65, of course, I just want to learn BASIC, and that's where I started. And my programs were simple games, and but as they started growing, as my skill set grew, I looking back on my own code, it became difficult to comprehend what did these 1, 2 variable names mean. What were all these GOSIPs numbers going to GOSIP 1000, GOSIP 2000? What did it all mean? And I started myself craving what 11 was offering, labels and long variable names and such. So then, how would one go about jumping into 11 when the time's right for you? You can grab it online via our file host. I put the link there. And I've also provided the modified version with some enhancements on our GitHub repo. And you can run it on either your real MEGA65 or the ZEMU emulator. So I'll just demonstrate that in the, I'm running ZEMU on the left-hand side here. So I can mount the disk, then boot into it. And you'll see it's booting into 11 now. Some things you can do while you're here, you can press F7 and it'll look for any labels. Labels are identified by lines with dots at the front. So here in this README file, Ubik has used them for like chapter headings. So if I want to quickly jump to a chapter, I can press F7, then browse this list of labels. I want to learn about compile, and I can read about compile and that sort of thing. If I want to load a different file, so maybe it didn't come up with that. Maybe I press F1. I can then type a file name. So I want to load the README again, README, enter, and it'll load up that file. So if we were to want to browse for examples, we can exit the IDE, and I'll just type a basic command to look for any 11 source code files on the disk, and we can get a list here. Maybe we're interested in one of these, let's say the Xanadu demos over here. So to come back into the editor, just press Shift or Run Stop, or on ZEMU emulate to Shift and End key, and we'll go straight back in, and I'll press F1 to load again, and I can type the name of the 11 source code I want to edit, and there it is. And you can use this IDE just purely as a text editor too, if you want to, just as he did with the README file. But yeah, it's maybe I'll make a new program here. I'll press F2 to create a new file, and just to demonstrate this hello world example, this output line is like the final dumbed down Commodore BASIC file that will be created. We can use a variable name with a nice long name. I'll put a label here, even though we don't really need one. And some simple things, what's your name? And then put it into that variable on that variable name. Print hello, name $. And then we can save it with the F3 key, give it a name, hello, whatever one.el. EL tends to be the suffix used for 11 source files. It's saved. So then I can press F5 to compile this from the source to this hello final basic code. And there you see, there it is here. What's your name? Future. There it is. If I was to list the the dumbed down Commodore version, that's what it looks like when it's dumbed down. Okay, come back with a Shift and run stop. The next one. So I gave a longer example on the right there with using labels. I won't type that all in now, but you can see I've got 3 GOSIPs in there. Each GOSIP is jumping to a different label. There's a hello subroutine, do some math subroutine, and a goodbye subroutine. And yeah, you can type that in your own time. Another feature I better highlight is that if you want to change the preferences here, change the color of the screen and such, what you can do is you can reboot your machine and press the letter P while 11 is starting up. And that'll take you to this preferences screen where you can toggle the border color, background, and so forth. I think the more exciting thing is there's a 80 by 50 column of text mode. So if you were to press F9, which I put is, how do I do? Control P is F9 in the ZEMU emulator. Then I can go into this 80 by 50 column mode, also text mode. But I won't do that for now, just for readability. You press S save to save and tab key to exit back into the editor. And Oh, another thing is if you have a favorite file you're working on right now, so maybe I was working on Xanadu, maybe I can load that up, xanadu.el. But every time I boot up into 11, maybe I want that to be my default go-to, then you can press the F14 key, which in F14 is the right Alt key and S, and that will save that. So if I was to reboot again, 11 will boot up straight to the your preferred source file that you were interested in, always going back to. So now what I've done in regards to the modified 11, I'll just run through that quickly. There was a little PC side tool I wrote called M65 Postbox. So that let me push my 11 source code onto the PC over the serial JTAG line. And that let me version control my source code, with whatever GitHub and such. And then because I came from BASIC65, which had its own shortcut keys, I tried to mimic some of those shortcut keys inside 11 as well. So escape J, go to start of line, escape K, go to end of line, and many other things, move forward a word, move backward a word. There's a fair few there. Some other things were I added a define preprocessor directive, so I could define some constants, some ifdef and endif, and some modest support for structs as well. Some modest support for copy and paste there. I put a few shortcut keys there. And also for long lines you need to type, I used the left arrow character to continue to the next line, so you can have very long lines. But if you have any queries on that, I'm happy to ping for more details. I can give more examples in the Discord chat. One thing I found was like this Xanadu example. Let's say if I was to press F5 to run this, this was a very large basic program, and you're going to see how long it takes to compile. It was super long. And that's what spawned the interest in how can we make this faster. One simple way is you can cheat. You can run 11 with the Xemu emulator, and that takes a special argument where you can set fast clock to be 200 megahertz. So that's one way to get around this issue. But then there was a more long-term desires to try and speed this compilation step up. And that's where it'd be great to just compile faster. And that's where the option of using Rust came in. Why? Another option could have been to use C. I just felt that we've got so much we've got so much C code in our MEGA65 ecosystem already. And personally, I found maybe there's a bit of apprehension into jumping into C code. It's a bit archaic and primitive by today's language standards. And maybe it's time for a new option. So for us to looking into a possibility. So that's what's led my interest into sort of exploring Rust a bit more with Wombat's assistance on this. And I'm by no means any expert, but yeah, we're learning as we go and bumping into different things. I got my, but yeah, I think
recording, just so you know, Gurce.
All right. Well, I can, yeah. I don't know how much to elaborate on Rust because I'm not that strong on the details yet. I know we're making progress in that compile phase, recompiling it. We also have our hurdles we'll have to jump through, like the amount of nice helper facilities we take from Rust adds to the size of the final binary. So we're sort of weighing those things up right now. But if you do want to follow the Rust journey more, we've got a Rust channel on our Discord server. So yeah, please jump in there, give us a ping, ask questions. We're happy to take it. So yeah, happy to leave it at that. Thank you very much.
Thank you, Gurce. This is 11 has always been one of those things that's aspirational for me. I would love to get in there, dig in, and try it sometime. It's been on, I think it's been on the Mega since the very first release of the SD package, and I just always go in and play with it and say, I'm not sure how I can use this. So thanks a little bit for that. We did have an interesting question. Dan said, it's not really a question, it was kind of a comment, but he wanted to know more about M65 Postbox. Can you speak to that a little bit more?
Yeah, it kind of takes advantage of the other serial comms tools we have to sort of talk between the MEGA65 and your PC. I just decided, is there a way I can use that serial comms to push a file across? And just for me, I want to see the file in text form so that I can commit it in. Maybe that might need a walkthrough of its own at some stage. If people are curious about that, maybe I make a video on that or something just to walk you through and share the source where it's on GitHub as well. But yeah, it probably warrants something like that.
And then Christian says, is 11 feature complete in comparison to BASIC65? Last he checked, some stuff wasn't complete. Or I'm sorry, last check, some stuff didn't compile. Apologies.
Oh yeah, I'm bumping into that. And I think that's also an advantage now that it's open source now. Like any missing commands, we can add them and others can benefit from that. Yeah, I've bumped into issues like that and added things as well into they may not be the commands you were looking for, or they may be, but yeah, you're definitely welcome to try the modern version. And if there's more missing things, we can add them too.
And then a final comment that was in there, there's a couple of folks that had mentioned how much fun it is to actually create on the MEGA65 and program. So 11 is obviously a great tool for that. So thanks for sharing that, Gurce. Perfect.
Happy to. Thank you very much.
And you were on time, so nicely done. Very well. All right, our next one is a really cool update. I got a little preview of this a couple of, actually last week, so I know this is going to be exciting for a lot of you. We're going to bring Lydon in, and he is going to talk about news on Slot Zero core updates and flashing. So Lydon, who is actually producing in the background, is now going to have to switch from producer to presenter, so we'll give him a chance to do that and bring him forward. All right, Oliver, it's all yours.
I hope this works. Hi.
It did, perfect.
So, okay, yeah, a bit of updates. I don't really know if I'm repeating the things I said in the trial run, but we will see. At least I have a bit more to show. So let me switch and remove the blurring. So here's my MEGA65 currently off. So what is this all about? So this slot zero updating, why would we update the factory default slot? So there are some bugs in the way the system starts up. This is mostly found if you work with cartridges, and this got popular with the recent additions to the C64 core. So that is why we stumbled over it. And this is why you probably want to upgrade your slot zero someday in the future. And the thing is, yeah, currently you need this little JTAG adapter. And yeah, the JTAG adapters are as bad to get as the MEGA65 because of FPGAs and stuff. So let me remove that. Yeah, and if you have no JTAG, yeah, how will you upgrade your slot zero? Because if you manage to break it because you have a HDMI connected with back power, I do not have an HDMI, as you can see. It's VGA all the way. Then yeah, what do you do? So, and let me switch on the screen. If we go in our flasher, yeah, then one thing is we can provide a way to rescue the system from the threaded ambulance mode. So I press the secret key press. You don't see it because it's hidden, but it's mega comma. And then I get a big warning screen. So you are about to do something bad. Please make sure that you have a MEGA65 core that boots in your slot 1. And then I need to confirm it. Then it will look for the upgrade 0 core file on my disk. Yeah, and then it loads it in. So the whole thing works by, yeah, essentially erasing the magic sequence at the start of a bit stream. And this is how the FPGA sees, oh, now a bit stream follows. I need to load it into the FPGA. And if it does not find it, it will skip until it finds this magic sync sequence. And yeah, to make sure that all is good, you see here is a CRC32 check that is done in memory. So this checks as if your attic RAM is good. We had those cores with bad attic RAM, some might remember. This also checks if the CRC sum in the core file is good. And yeah, then I can flash my slot 0. And if then the power fails, for example, or my little child switches something off, then slot 0 is broken because, yeah, it's gone. It's not good. In the past, this would have meant that the system would be in this dreaded state, which is called ambience mode, where the two lights are blinking blue. So this is because the sync sequence was written first. And then the flashing was interrupted and not the whole core was written. So you have an incomplete electronics in your FPGA and it does not run. So you see, I'm pressing the no scroll key. Why do I do this? Yeah, because the new sequence, oh, you see, green light. The new sequence works the other way around, essentially. It will first erase slot 0's sync sequence, and then it will start flashing the core backwards from the end of the slot and flashing the sync sequence and the core header last. So I interrupted the flashing somewhere in the middle. And so my slot 0 is broken and it will skip to slot 1, as you can see. And slot 1 boots. And in slot 1, there's also a new core flashing core. So I can again confirm. Let it load, and then it will flash slot 0 again, and I will have a running system again. So that's what the new core will do. And it will obviously make the system, my screen is blank. I hope this did not affect my output. Okay, so.
We can still see you, you're okay.
Yeah, okay, good. Sorry. Where was I? Cartridges. So the cartridge that broke everything is the Ultimax cartridge. Essentially, the Ultimax cartridge does overlay the ROM. And because of that, you can see the counter goes backwards. No? Because of that, MEGAFlash did not run because MEGAFlash uses the ROM to output data text to the screen. And yeah, that did not work. So this is also fixed. And another thing that the new slot 0 does, or the new MEGAFlash does, is it allows you to tag slots for a certain cartridge. So you can see slot 6 is tagged for the C64 cartridge. Slot 5, sorry. Slot 6 is tagged for the 128 cartridge. Yeah, we don't have a 128 core, but we can detect the cartridge. And there's also a MEGA65 cartridge. And you can tag a default slot. This is this one. You see there the pointy brackets, so the lesser than and the greater than sign instead. So this is my default slot, not 1 or 2. It's not affected by the dip switches. I can set it. So currently you can set it before you flash the core, but I will be adding a feature so that you can press edit here and then change the flags and make another different slot, default slot or C64 slot. And it can be only one slot, obviously, because how should the MEGAFlash decide which of the multiple C64 slots you have? So currently it uses just the first one. And you also see only the first one. The C64 cores are already tagged as the C64 cartridge slot. So they have the flag set in the core file that is distributed. How can we see that? For example, if I put in this cartridge here and switch it on, then we can see we go right to the C64 core in slot 6, and then some program should start. Sometimes it does, sometimes it does not. We give it a quick reset because perhaps it works then. It might be that I misplaced the cartridge. Sometimes this happens. Or it's just, in German, we call it the Vorführ effect. I don't know how, there is it, eye of the beholder. Okay, and the other thing I could do is I place this one in. Let me press no scroll. I can show another feature. So if I press help, I get all the information about what is my core that is currently running, what is the version of MEGAFlash, what version is in slot 0, what hardware is this running on, and then below that you see it detected a MEGA65 cartridge and it will boot slot 3. Ah, nice. There's even a secret press to get more information, some debugging information, and there you can see the secret MEGA65 header, which is found in memory. So if we now boot in the MEGA65, there's still no startup code for a MEGA65 cartridge in the ROM. So I need to emulate this. So how do I do this? I copy, I just copy the ROM, which from the cartridge, which is in hex 400 and then 8000 into run. And then call it up. And this is the code that is in the cartridge. My Mandelbrot Explorer, obviously, because that was easy to put onto the cartridge. But I'm working on a shooty game. So perhaps we see that soon.
And we're at our 10-minute mark for you, just for.
Yeah, wonderful. Okay, then I can perhaps just put something into the camera. So this is, you're already seen it, perhaps. This is the R4 board, which could be seen in Paul's blog post. So this will be the boards in the next batch. There are some bugs fixed in this version of the board. And it has some changes, like no max 10 FPGA anymore. So less FPGAs means easier to source all components. Also has a different RTC and a super cap, which keeps power for some time if you change the battery of the RTC. And we have lots of shielding because, yeah, the R3 boards did make some electronic noise, I heard. Yeah, what can I say? We are working on this. It's already working. It's in the development branch. Yeah, and I think it will be soon with the next machines. Do we have questions?
Let's go back to the core for just a minute. There was a question about when it would be available for everybody, and Dan mentioned that everybody could start testing now. So if you could answer, how can people help with testing and when will it be available?
Yeah, on the Discord, there is where is it? In the release test forum channel, there is the slot null flashing recovery test. There are instructions how you can help testing. This is currently for JTAG owners because it's still testing, so it could break. So you should have a JTAG to reflash your system. And this is in the 6i83 card flash branch. There will be the release tests for the next release. So the next release will be the release that is for the batch 3 systems. Will start soon, I guess, as soon as the flashing works well. And then we will also do a post in the release test. Yeah, this board size of the R4 is absolutely the same. It fits, I can show it, board size. So R3, R4, it's the same.
So while you have it in view, Mark wanted to know if you can pull the cover off that FPGA.
The what? The cover? No, I don't pull covers right now live.
No is the answer on that one. All right, good. How many units are planned to be released for the sale of the next run?
Oh, a very good question. I don't know the answer to that, but it's no, I don't know the answer.
We will see if we can get some kind of response to that.
Yeah.
I'm not sure any of us will have the answer, but we'll see if we can get a response to that and put that in the MEGAVision Discord, which again, if you want to ask additional questions, don't forget to go to mega65.org/chat. Look for the MEGAVision channel. So, all right, Lydon, we're going to send you back to your director and producer responsibility. So thank you so much. Great presentation. I know there's a lot of excitement about being able to slot Core 0 and the new board. So looking forward to more information on that. Now we're going to go into another core, which is really exciting. And it's a showcase of the C64 for the MEGA65 core, which this has been in development for quite some time. So Amok Phase 101, we're going to bring you on and let you talk about that with us. And I know there's going to be a lot of excitement about this and to see what new features are available in the what is this, a version 5 core?
Yes.
And are you, we got you off mute, there we go.
Yes, it's version 5 of the core. And currently it's a version number 5. And so, yes, I'm on phase 101. And so to be as clear as possible, I've not been involved in the development of the C64 core. I've just been involved in testing the C64 core. And the core has been written by Mirko, also known as C2002, and Michael, I always forgot his name, but his name is Michael Jorgensen. And they both have been working on the core for many years now. And so we have now the V5. And something I might want to clarify first, because it didn't look to be very clear for anyone, is that the C64 core, sorry, I made a mistake. So just to be as clear as possible, when you do this, okay, because it has been asked on Discord, when you do this, you are still running the MEGA65 core, okay? You are just running the simulated the C64 mod, which came with the C65, okay? So this is not the C64 core for the MEGA65, okay? The core we are talking about, okay, it's really an independent core, okay? You're not running the MEGA65 when you are running this very specific C64 core, okay? And so you have to flash the C64 core in the slot you like, okay? And you start it very well. The most simple way to start it is doing this, okay? So just take a bit of time to boot, okay? And then you have it. And here you are. It looks quite similar to the C64 mod of the MEGA65, but it's really an independent core. So where is it coming from? And actually, from an history perspective, this core has been ported from the C64 core, which exists on the Mr. FPGA platform. The Mr. FPGA platform is one of the most popular FPGA platforms. It has lots of cores for nearly all 8 bits and 16 bits computers. Also the same for the consoles, okay? And the great thing is that all these cores, they are open source. Of course, open source does not mean that you can just take what has been written for the Mister and take it and run it on the MEGA65. You have to port it, okay? And so this takes quite some time. And in order to simplify the port of this core, and possibly also in order to simplify the port of other cores, okay, a framework has been written by the team, okay? It's called Mr. to MEGA65 framework, and it is the port of all the cores coming from the Mr, okay, to the MEGA65, okay? So basically, so this is the C64 core, okay, and you have a menu, okay, in which you can configure the way you want the core to behave, okay, and you have the different options, okay, and basically this is for the V5 version, okay, and in the previous version, what we had actually, we could only load disks. Okay, we can only load programs for disk, and that was basically the only source where we could load programs and run it. And something which is very important to specify is that we are talking about a C64 core, but it's much more than a C64 core. It's a core which is implementing a C64 computer and also a 1541 drive, okay? And this is really important to specify, okay? I will tell you later, okay? But this means it's quite complex because a 1541 drive is for itself, it's a computer, okay? It comes with a 60502 CPUs, okay? So it's like as if you had two machines in one machine, okay? So basically, we still have this, okay? We can basically mount drive, okay, and just like do this, okay, and demos, and so I took a demo from X 2023, okay, and you just do like that, okay. So something very crafty. Okay, I took this one because it loads quite fast, okay, so that you are not going to wait during 1 minute to run the demo, okay. And I have to apologize in advance because I've had a technical issue, so you won't hear any sound, okay, from my presentation because I cannot stream the sound, okay. And also keep in mind that it could be running at 30 FPS, okay, and not 60 FPS. So this is really important to specify because when you run it on your one screen, it's really running at 50 frame per second, okay. So I run it, okay. So again, it's really unfortunate you don't hear the sound, but we really have a really cool sound emulation on the system. And something I have noticed with this V5 version is that in between V4 and V5, lots of stuff has been rewritten for handling interrupts. And if you run this demo on V4, okay, you will notice some glitches in the demo. And I was very happy to notice that with the V5 version, okay, which comes with a new interrupt system, well, the glitches in the very specific demo have disappeared, and also in other demos which were running a very big sprite multiplexers with in the background lots of raster bars. Okay, it's very complex to have something without glitch on a demo when you have a multiplexer combined to raster bars in the background. Okay, so while this demo is running, okay, so we have different possibilities in terms of outputs. Okay, so you won't see it here, okay, but we have HDMI output, and the core supports different screens. Okay, so different format of screen, so 5.4, 4.3, and you can run that at 50 hertz or 60 hertz, and but HDMI, okay, is not the only option. Okay, you can run it on a true retro monitor. So I will switch my my screen, okay, and let me do it here. Yeah, no, that's me. Okay, so here you have the core. Okay, so sorry because it's quite hard to capture the output, but on the left side, okay, you have the core which is running on a HDMI screen, and on the right you have a CRT screen. Okay, so basically the output is coming from the VGA port. Okay, and I have a special cable which I also use with the Mister. Okay, but and which is connected to my TV. Okay. And of course, you also have the sound which comes from the TV. And I am really sorry I can't capture this very well, but I can tell you that the picture is just impressive. Okay, so this and you notice that you can run it on both screens at the same time. Okay, so I would switch to the, I would switch here to this. Okay, so, okay, so I will reset the core because I want to show you. So basically, we could load from a in V4 we could load from a D64 file, and now we have another option. Okay, and sorry, I am going to disable CRT emulation because well the capture it's not captured correctly, and but you can activate it when you are on your HDMI screen, and it's really nice. And so now we can also load from PRG files, whatever they are. Okay, you can load programs directly. Okay, so if I go here, PRG, GFX. Okay, so and it's loading quite fast actually, and so, okay, so you can load very quickly any file you like, any PRG file you like. Okay, let's go for this one. So any PRG file, basically, you can run it now on the version number 5 of the C64 core. Okay, so here, and I'm going to reset it because sometimes I have some issues.
And we're butting up to our 10-minute warning, just as an FYI.
Sorry?
We're close to our, we're right at 10 minutes.
Oh, okay, I did not see. Okay, what's important to tell? So what we have now for the cartridges. Okay, we have we can now start the core with any cartridge plugged, nearly any cartridge plugged into the MEGA65. Okay, so we just, so that was shown just previously with the with eye of the beholder. Okay, and basically when I say any kind of cartridge, okay, basically you have all the cartridges that are coming from the market, okay, the older one, and the new cartridges which are produced today. Okay, they basically all work on the MEGA65. And also what's important to say is that the MEGA65 now support easy flash cartridges. Okay, you can flash them directly on the MEGA65. You can boot from them on the MEGA65. It also supports Easy Flash 3. It also supports Kung Fu Flash. Okay, so a lot of stuff, nearly 6 months of development have been spent to be able to support cartridges and have the best retro experience ever on this core. Okay, something also that we have very quickly is that we also have RAM expansion unit support. So there are many very great demos which are using this RAM expansion unit, and they work very well with it. And also you have a game like Sonic on the C64, which is using RAM expansion unit and which runs without having to load. I mean, you load the game from the very beginning, and then you don't have to load anything at all. Okay, and of course, in addition to hardware cartridge support, we have CRT. We have CRT emulation support. So basically, all this type of cartridge you see is here. Okay, so for example, Gmod 2. Okay, and you go and you can load. I would say 99% of the simulated cartridges they work on the C64 core now. Okay, so and well, that's it. And as other options you have, okay, regarding the seeds, okay, now what we have, so of course we used to have the two different seeds in V4 version, but now you can have stereo seed. I mean, you can have two seeds running at the same time. Okay, you can decide which one you want on the left and the right side. Okay, and also of course you can choose on which address you want the second seed to be running. Okay, because you have lots of musics which either run on D420 or D500, and so all these are supported. Okay, so this is from the from a music perspective. So you will have lots of fun with this. Okay, and something I would have liked to show, but we are running out of time, is that now the C64 core support devices which are connected to IEC port. Okay, so basically, okay, if I show you this, let me show you. Blah, blah, blah. Okay, so basically something like that, which is a Pi 1541. Okay, you can connect it to the MEGA65 directly. Okay, and as far as I remember, you can also connect a true drive. Okay, a true 1541 drive on your MEGA65, and the C64 core will be able to handle it. You just have to remember that since the internal drive of the C64 is 8, the drive ID, then any additional drive would have to be set up with a different number. Okay, but all this work on the C64 core. And very quickly, and one last thing, okay, and I hope I don't forget anything, but we have the ability to use GFIDOS, okay, which is a kernel which is normally installed on both the Commodore 64 and its drive, okay, and which enable you to increase the speed of loading the games from D64, okay. And basically, of course, you have to provide the GFIDOS ROM, okay, but actually you just have to choose it, okay, and you are immediately shifted to the GFIDOS, okay, and this drastically improves the loading times from D64, okay. And so to finish, I would say when it comes to accuracy of the core, okay, because it's always a question we ask ourselves, okay. The way we have worked on this is by testing lots of demos, because testing again, you can't reproduce always the same situation, okay. It's quite difficult. So we have tested up to, I would say, nearly 200 demos from the best demos, and I would say except 5 or 6 demos, okay, they're not breaking, okay, but they have glitches, something like that. But all of the demos, they are running perfectly well, okay. And so well, so over time, okay, the core keeps improving. Okay, there are of course other things to implement and to improve, but basically it's the experience is really incredible, especially because it's inside the MEGA65. We have a great keyboard, okay, and so it's like having a new retro machine, okay, with the C64 core inside. So I didn't expect that 10 minutes would be so short. So yeah, I thought I would, on you. But I thought I would run out of stuff to show. Okay, I may have spoken too much. I'm sorry.
Oh, that's okay. This is a big one. I think you know, the MEGA65 is the best 8-bit computer, but now the MEGA65 is now the best modern re-implementation of the Commodore 64 with this core. So this is amazing work. I can't wait to, as a matter of fact, I just want to jump online and grab that core right now and install it on my MEGA65, and we'll probably do that here soon. So how do they get a hold of that would be a quick question. How can they get the new core? Is that available at the files host?
Yes, it's available on the file host, and I have provided all the links in the summary of this tonight event. Have provided the links where to get all the 64 games collections on the collection we used to test, all the demos. There are lots of links to get the core and to easily find the game collection, CRT, D64, and so on. Okay, so all this is provided.
Great. Thank you, Oliver. We really appreciate it. And thank you for all the work that you've done on this. This is a big lift. And I know the MEGA65 community really thanks you for this and look forward to the future. I mean, what more can you possibly add would be a question, but we'll leave that for another time. So thanks again.
And people, please do not hesitate to come to the Discord. And if you need some help, I will be happy to help you.
Great. Thank you so much. All right, our last one is a presentation that was pre-recorded, and I am pulling that up now from my location here. Let me go ahead and get that going. And as a reminder, while I'm pulling this up, don't forget, again, the Discord, mega65.org/chat, and then look for the MEGAVision channel. So I'm going to open up this video. This will be our last presentation. And then at the end of that presentation, I will give you just a couple of wrap-up comments, and then we will be done. So this runs about 15 to 16 minutes. So sit back and enjoy Just Pixel by Mark.
Yeah, welcome to my presentation about Just Pixel. Yes, this is about graphics for the Commodore 64 and of course for the Mega 65. My name is Mark Teufel and I'm 47 years old and I'm living in Germany. In the scene I'm active with the nickname Şeytan, and this is the Turkish word for devil, and devil is in fact the English word for Teufel. I'm a graphican and a coder. So what is Just Pixel? It's just a tool to make pictures, logos and sprites, but doing it the old way. That means by setting pixel per pixel. The tool is heavily inspired by Zomatic, which was developed by the legendary demo group Panoramic Designs. And this is exactly where I want to start now. I want to start off with a little demonstration of the original Zomatic. Starting it this way makes it hopefully easier for you to understand my motivation. What you see here is Zomatic running inside the Wise emulator. Zomatic is a paint program for the Commodore 64, concentrating only on the multi-color mode. Just Pixel, as you will see later, supports more formats than only multicolor. Zomatic was not meant to be a paint program only for artists. It was also made for programmers. If you press the F7 key, you see there are a lot of coding specific features like replacing and rearranging colors, converting everything into just 3 colors, which was very important in order to convert the bitmap into characters. And yes, it was possible to convert between bitmaps and jarsets. It was even possible to convert parts of the bitmap directly into sprites. I already prepared some pixels for you, as you can see here. One moment. You can use Zomatic to paint with mouse or joystick, but at least for me, the best feature is you can pixel perfectly with cursor keys and setting pixel by pressing just 1, 2 or 3. On the bottom of the screen here, you see the 3 gray colors I selected to be used when pressing 1, 2 or 3. Just to demonstrate, I will set some pixels now. And this was how I set my pixels in the good old day. So here I am in zoom mode. This is the graphic in a preview, and here I'm back in zoom mode. In the past, I used Zomatic for mostly all graphics I did. In Reflex, we did own versions of Zomatic back then, with which it was possible to pixel in other formats than multicolor. High-res, FLI, and even high-res FLI were possible. All these were advanced graphics modes, very popular in the good old days. When I started with the Mega 65, the graphics environment was of particular interest to me. That's why I started the Just Pixel project, a modern tool to pixel like I am back in the 90s. Just Pixel supports different graphic modes. All modes, except for one, can be used on the Commodore 64 and the Mega. The most simplest mode is for sure high-res. High-res gives you the resolution of 320 by 200 pixel. The whole screen is made out of char blocks, each made of 8 by 8 pixels. One big limitation of this mode is that you can only use 2 colors for each of the 8 by 8 blocks. It is very impressive what works of art some artists have achieved with these limitations. Look at the slide. The next mode. The next and very popular mode on the Commodore 64 is multicolor or multicolor bitmap. This mode gives you the possibility to use more colors, but think we had only 64 kilobytes of RAM back then, you lose resolution. That means you get a resolution of 160 by 200 and each block consists now of 4 by 8 pixels only. But, and that is the good thing, you can have 3 colors per block now. Multicolor is for sure the most used format on the Commodore 64. In just pixel, this mode has the most features, as my game blocks, which I'm working on actually, is using multicolor bitmap graphics only. And last but not least, we come to a completely new mode, which is only available on the MEGA65. Full color mode, or FCM in short. Thanks to the WIC4 chip we get with the Mega, there is no longer the need to use advanced modes like FLI, High-Res FLI or mteufel, which was invented by Crest and which is a very cool graphics format. With FCM you can make full screen graphics with a resolution of 320 by 200, and in each 8 by 8 pixel blocks you can use up to 16 colors. That's great. But wait, you can use 16 colors out of a color palette of 256 colors. And you have 4096 colors available in total. But that's not all, my friends. Full color mode is not a bitmap mode. It's a big character set. That means you are using FCM graphics as a charset, and you get a lot of benefits out of it. Handling and working with character graphics makes life much easier for developers. Scrolling character in all directions is much easier than doing it with bitmaps. Think about parallax effects. Doing it with bitmaps is a pain in the ass. Doing it with character sets, for sure, is much easier. Okay. This is just Pixel in the browser. As you can see on the bottom, we are in the multicolor mode. If you want to change the mode, you can go to the toolbar, which is right here, and you can press this new button, and then you can switch between the 3 different graphics modes, which I described earlier. In order to set pixels, you first have to select the colors you want to use, and for this you go to the bottom and you activate the slot where you want to put the color in. This slot here stands for the key 1, and this is key 2, and this is key 3. So I put my 3 gray colors into it, and then I can use the cursor keys to move the cursor, and I can press my keys here 1, 2, 3 to set the pixels. If you look here, you see the preview of the graphic, and the preview I can zoom in or zoom out. If you want to delete pixels, you can press the delete key, and this will delete all the pixels in the block. If you want to paint circles or lines, you can select a color, for example this one, and then you go to the starting point of the line, you press the L key, and with the cursor you can define the line. And if you press L again, the line will be painted and the preview will be refreshed. You can do the same with circle or ellipse functionality. So you go to the starting point, you press a C, And by using the cursor keys left and right, you make a circle with the same radius. And if you use the cursor key up and down, you can make ellipse kind of things. And again, if you press C, the circle will be painted. Another cool thing in Just Pixel is that you can save and load graphics. So for this, we have in the toolbar this save button and here the load button. This is the down. In fact, it's the download button and this is an upload button. So if you save, you can enter a file name and then the file gets downloaded, and the file that you will get is in the Koala Painter format. So this is a very common format for Commodore 64 programmers. That means that's a binary format that can be used directly in your programs. But now I will load some pixels because I would like to show you some more cool features of Just Pixel. So here's the upload bitmap dialog. This is where I can upload Koala Painter formats, and this is for the future where you will get a converter to convert PNGs into bitmaps. Not yet available at the moment. So I load a pixels file, and where is my blocks logo? Let's load this one here. And here is it. You see, this is the blocks logo from my game Blocks. And what I want to show you now is the copy functionality of Just Pixel. So in order to copy parts of the bitmap, you can move the cursor to the starting point, and then you press the M key for mark. So this brings a little marking point here, a little marker here for the starting point, and then you go to the end position. Let's say we would like to copy this whole part until here. Now we have defined an area, and this area we can copy now. With the key Control V, I can copy it. And as you can see here, it's copied. But that's not all. I can also copy it mirrored. For this, I press Shift and V, and then I get a little dialog. And in the dialog, I can select between different options. How to mirror. Mirror horizontally or mirror vertically. I would like to mirror vertically now. And now you see, it's it's now mirrored. Perfect. I like it. I like this feature. Okay, and now it comes to the question, how can I use the graphics in my assembler programs? First option is to pixel some graphics and to download it as a Koala Painter picture and use the binary file in my assembler code. But there is another option which I implemented especially because I needed it. So here we see the graphics for my game Blocks. All graphics are in one big file, and I have decided to make an exporter. So that means I can define an area. For example, this block here, I would like to use it in my program. Then I can define an area with the M keys. So now here is the area. This is exactly the area I want to export. And then I press the E button, and that gives me the so-called byte dumper. And in the byte dumper, I can select in which format I would like to have these pixels to be exported. So I can select between Acme assembler, between byte, and I can also export basic code. And what it gives you is all the data you need for the graphics. So there's one part for the bitmaps. These are the bitmaps here. And here we have the values for the color RAM, and these are the values for the screen RAM. And all the three areas make the bitmap graphic. And And what you can do now is you can select this source code here, copy it, and then paste it directly into your assembler program. And this is what I will show you next. By the way, the same functionality I implemented for sprites. Here we have some bitmap graphics with only 3 colors for sprites. And if I would like to export, for example, this A here as a sprite, I do exactly the same. I mark the area, for example, this one, and then I don't press the E button for export, I press the S button for sprite dumping. And this gives me the sprite in kick-ass assembler format. Exactly the same. Easy idea, but very effective. And now let's go to the assembler. Okay, how did I use the graphics in my program? This is Visual Studio Code, and in Visual Studio Code my blocks project is opened. Here in the source folder there's a lot of assembler files, and interesting now there are 2 files, which is the sprites ASM and the graphics ASM. So let's look into the sprites. It's just bytes which I dumped into the file, directly exported from just Pixel. And I'm using it directly. It's really easy. And for the graphics, I did some tables. So here's a table with high byte and low byte to the address of the starting point for each graphic. So for example, here is the gray 1, high and low byte. And then I have here the areas gray 1, gray 2, and also, again, the exported bytes from just Pixel. That's it. Easy and effective. Thank you very much. And
all right, and thank you to Mark for that presentation. Apologies to Mark when he sees this. Unfortunately, he had a picture-in-picture of himself in the upper right-hand screen, and because of the way Zoom works, it was casting the presenter screen or the presenter's information, which was me at that point. So apologies for that, but hopefully you all agree. That is a really sweet tool. It's an online tool, so links for all of that will be in the wiki. I noticed that in the chat, we just posted the link to that as well. So that concludes our first ever MEGAVision, all 9 presentations. We did have a couple of presenters who have been postponed for next time, which seems to suggest to me that Gurce and Lydon will be preparing another one of these in the future at some point. Do either of you want to speak to a timeline for that, or would you like to leave that vague?
Happy to leave it in the open. I mean, hopefully this will encourage others in the community that want to present their project. Please get in touch with us. And yeah, it'll be great. Once we've got a few queued up there that want to show off their wares, yeah, let's go for it. Let's do this again.
Yeah, I think this was an excellent way to showcase all the great things that are happening in the Mega65 community. Just again, don't forget mega65.org/chat. And then the MEGAVision channel, if you want to continue to have conversations with anybody who's presented, you want to share ideas, you want to ask them where to find more information, that is a great place to do that. Now, this was a virtual presentation. I know all the folks at mega65.org are actually thinking about an in-person event eventually. At some point, we would like to do this in person as a computer show. So you want to join the Discord so that you have all the information there and can learn about that. Let's give a big virtual applause to Gurce and Oliver for arranging this for us in the chat room. Leave your applause. Those of you still left in Zoom, make sure you give an applause and thank them for that. And again, stay connected to the chat so that you can see that. Remember, the video description down below will have a lot of links in there that you'll need or want to, so that you can get more information. But also, we will post time codes down below when this is available to do so, so that you can bounce around if you want to go back and watch a specific presentation and get additional information. So really looking forward to that. So normally what I do in my live streams is I give us the Commodore salute. with a big retroCombs out. And I think I'm just going to have to do that here because that's kind of my thing. Just for the rest of you, if you're curious about my stuff, retrocombs.com or retrocombs.com or YouTube at retrocombs. So feel free to check that out. So here we go. retroCombs out. Thanks for everybody for joining MEGAVision, the very first MEGAVision ever. So what a blast it was. And thanks again to all of our presenters. We will be in touch. See you guys online. We'll see you in the Discord. Thank you so much.